Let us now return to Visual Studio for the final demo of this course. I will introduce a unit testing project and we will write some unit tests to test the view models, the center of our MVVM application. We will also need to introduce some mocks, so fake versions of some of the services we introduced earlier. We're going to test the work that we've done so far in some unit tests. So let us start by adding a unit testing project to our solution. I'm going to add a new project and search here for XUnit. Then make sure to select the XUnit test project.NET Core. And let's call that project Bethany's PyShop stock app.tests. This project will need a reference to our core project. That's the code that we'll be testing. Now what am I going to test? Well, I'm going to show you a couple of unit tests for the PyOverview view model. So this one. If we look at this code before we can actually test it, there is actually something that is still bothering me a little bit. Take a look right over here. I am in fact in the onload command as well as in the onPyChange, by the way, directly using the app.pydataservice.getAllPys. Imagine, like it is here by the way, that this PyDataService is using a repository directly. There is no way that when I want to write a unit test for this onload command that I can do this without having a dependency on the PyDataService. That is really not that good. So what I should actually be doing is taking out this dependency and letting it be injected into this view model as a constructor parameter. So let us refactor that to do so. And once things are refactored, then we'll be able to create our unit test with ease. So I'm going to change the PyOverview view model so it accepts an iPyDataService and an iNavigation service. I'm going to create two private fields of the same types. And in my constructor, I'm going to use these private fields to capture the passed in values. So now our local fields point to the values passed in as parameters. This way, I can now remove pretty much everywhere here the tight coupling, the direct reference, let's say, to the app.pydataservice. I'm going to change this code and let it use the PyDataService instead. And we're going to do the same in the load command. There we go. We have the same problem also with the navigation service. So let us also remove this tight coupling to the app.navigation service and replace it with the navigation service, the local field. This needs to pass in the Py, and over here we'll do pretty much the same. So let me copy the navigation service here and replace this also with the local field. Let me do the same also with the PyDetail view model. I will show you the result. So here is the updated PyDetail view model. I also have two local fields, and I'm also passing in an iPyDataService and an iNavigation service that I store in these local fields. In the onSave command, I use the PyDataService to add or update the Py, and I also use the navigation service. Let's build things. I will get an exception. And the exception is situated in the view model locator. Of course, we have not made the change over there, so let's go there, because it's still expecting the parameterless constructor. I've now updated the code. As you can see, the constructor now accepts the app.pydataservice and the app.navigation service, the ones that we were previously using directly in the view models. That was not good. We had defined the dependency directly in the view model. Now I've moved that away to my view model locator, the one that instantiates the view models, and that will inject the dependencies. My view models are now clean. I can now also use my view models and pass in a mock version of the dependencies. Before we do that, before we write the unit test, let's make sure that everything still works. So let's load the Pys, open the details, edit a Py, save it, and everything still works. Alright. I'm now much happier because my view models are not having tight coupling. They don't have a direct dependency on their services anymore. Now they are testable. This is where we need to be. So let's try that out, and let's now go to the test project. So we are going to be testing the PyOverview view model. that needs a PyData service and an iNavigation service. So we'll create a mock version of both of these. I'm going to start with the PyData service mock that I will create manually. I want to be able to pass in some mock data through a PyData service and use that to make my unit tests. So I am going to create a new folder here, and I'm going to call it mocks. Now go back to the assets, and under mocks, you will find the mock PyData service. This mock PyData service contains hard-coded data that we will use to create unit tests and to make assertions. It is of course implementing the iPyData service. That's the one that was created in our original project. In here, I use a hard-coded list of pies, a method to retrieve all the pies, to add a pie, and to update a pie. So this is the hard-coded data service that does not use a local database or a remote service. It uses a hard-coded list of pies, so I can use this to write my test against. Next, to be able to test my PyOverview view model, I will also need to mock my iNavigation service. Well, in my unit test that I'm going to write, I don't really need an implementation of the iNavigation service, a mock implementation that is. So I'll use a framework that I often use, and that is the mock framework. So go here to Manage NuGet Packages on the test project and search for mock and install that package. Mock is really a mocking framework. It will allow me to really easily create a mock version of an interface, for example. That's what I will be doing. So I'm now going to add the unit tests, and I will take you through the tests. Alright, here's our first unit test. As you can see, it is marked with fact. That's the way for XUnit to know that this is actually a unit test. The first thing that I'm going to test is that after the construction, the pies collection is not null. So basically, I'm going to be running the constructor, which needs the PyData service and the navigation service, and I want to verify that after the execution of this constructor, the pies, this one, is not null. Now before I can call the constructor of my PyOverview view model, I need the mock version of the PyData service and the navigation service. We have created a mock version of the PyData service. This one, we can simply instantiate that. That's what I'm doing here. For the navigation service, I have not created a mock version. I use the mock framework to create a mock version of that iNavigation service. I then call my constructor, passing in the mock versions of both my PyData service and my navigation service. Then I can make an assertion to test that the PyOverview view model.pies is not null. We successfully created our first unit test. Let me add another unit test. The second unit test is going to test that after calling the load command, the pies have effectively been loaded. So I'm actually going to test that this code executes correctly. And I'm not going to use the PyData service of the original code. I'm going to use my mock PyData service. So I again create a mock version of the navigation service and my own mock PyData service. I then construct my overview view model and I call the onload command. I then ask what is the pies of the PyOverview view model. I'm going to check that this is not null, and because I have a hard-coded list of data in my mock PyData service, I know that the amount of pies in there is 10. That's 10 pies over here. So I can now make sure that after calling the onload command method, I effectively have 10 pies in the pies collection in the view model. Now these are two sample unit tests that show that our view models are easy to test. Let us, to finish, make sure that our tests effectively are running. Let's go to test and then call run all tests. And as you can see, our two tests have completed successfully.